Okay, let's see question D, problem D of round 841. You're given an n into m grid in which each cell is occupied by a cuboid building of height a of ij, and you need to find the size of an L into you need to find a L into L size grid in which every building of that grid has minimum height of L. You need to maximize the size of L. So basically, let's see, if you have a grid given, like you have given a 4 into 4 grid like this, you need to find out a grid inside this grid in which the height of every element inside the grid is greater or equal to the size of the grid. For example, if you see, let's take L equal to 1. So if we take any of the grid, even if we take this grid, 1 into 1 grid, the size of the height of the element in this grid is 1, which is greater or equal to 1. So that means it's true. Let's take L equal to 2. If we take this grid or any of the other grid except, okay, let's first take this grid, 9, 6, 8, 7, everyone is greater than 2, so it's fine. But if we take this grid, 1 is less than 2, that means this grid is not possible. But we can have like multiple grids in which all the elements are greater than 2, so answer would be true for this L equal to 2. For L equal to 3, if we take this grid, it's not possible because 2 is less than 3. But if we take, like, let me change mark, if we take this grid, just a second, if we take this grid, 12, 9, 6, 4, 8, 7, 9, 13, 17, every element is greater than 3, that greater than equal to 3, that means this is true. So true, true, true. Now for L equal to 4, we just have one grid in which 2 is less than 4, so we can't do. That means the answer equal to L equal to 3 if we have like this test case. So one thing to notice in this is that, like, if you see that for L equal to 3, if the answer is true, then it is given that for L equal to 1, 2, this 3 minus 1, 2, it will be true for sure. Because if there's a 3 into 3 grid in which every element is greater than or equal to 3, then it's obvious that inside the 3 into 3 grid there will be a 2 into 2 grid, 1 into 1 grid, whatever, in which elements, all the elements would be greater than or equal to that L. Right? It's understood, right? Because if all the elements are greater than 3, then of course all the elements are greater than or equal to 2 also, and 1 also simultaneously. So what we can say is that if for some grid you are given L which is giving true, so it will mean that for every 1 to L minus 1 size of grid, the answer would also be true. This is the main point to notice in this question, and due to this due to this observation, we can apply binary search on answer on this question. It's a pretty standard format, and for those of you who don't know what is binary search on answer, I can't help you at this point of time. You can just go on, use some Codeforces blogs and check out what is binary search on answer, but I'll just tell you what to do after that. Okay, so how can we apply binary search on answer of this question? We are given, okay, what's the max size of L that we can use in this question? That would be the size of N or M. If our grid is 5 into 6, then of course the max size of L can be 5 only, because we have to use a square grid and we can't use a grid of 6 into 6 in this. So the max value of L would be 5. So and our lowest size would be 1. So we can start for our binary search from L equal to 1 to L equal to 5 for like this test case. Now the thing which we need to focus on is that how can we find out that we have a grid? Like in this question, we can see that we have a 3 into 3 grid. But let's see, if we have L given, how can we find out that we have a subgrid in which every element is greater than or equal to 3? How can we find that out? That's the main problem in this question. Let's solve that first, and then I'll apply the binary search. Okay, let's see. we have a grid. If we need to find out if there is a subgrid of L equal to size 3, L equal to 3, which all the elements are greater than or equal to 3, then how can we do that? L equal to 3. What we'll do first is we'll transform a grid into a 0 1 grid. How can we do that? If the number is less than or equal to 3, then we make that element 0. If the number is greater than 3, greater than or equal to 3, then we'll make the element 1. So we'll have this kind of grid with us. Now the second prerequisite for this question, 2D prefixum. Now if you don't know what is 2D prefixum, I'll give a link in the description. There's an article on USACO for 2D prefixum, and you can refer this and then come back to this question, to this editorial. Okay, so you'll have this grid with you. Now what I can do is that you can see this is the grid which will give us our answer, because in this grid all the numbers are greater than 3, right? Now what we can see in this grid, the sum of elements in this grid would be equal to L into L square, yes, will be equal to L square, 1 2 3 4 5 6 7 8 9, right? Because all the elements are 1 in this grid, so number of elements in the grid, that is equal to L square. If L would be equal to 4, let's see if it would be 1 in some other test case. So if for L equal to 4, if the sum of the subgrid is 16, then that would be true, that is 4 square. Okay, so this is that, and yeah, okay. So how can you find out the sum of this subgrid? 2D prefixum. We can make a prefixum on this grid and then check each and every 3 into 3 subgrid. First we'll check this subgrid, then we'll check this subgrid, then this subgrid, and then this subgrid. We'll have to check all the subgrids of size L into L in our main grid, right? And whenever we get a sum equal to L square, then we return true, and if we don't get, we return false. Now how our binary search will work? In this test case, low will be equal to 1, high will be equal to 4, then we go to our mid. If in mid we get true, that means we have a grid of size 2. Then we know that we also have grid of 0 1, also not 0 1. So that means we'll move our low to mid plus 1. So low will become 3, high will become 4, we'll go to 3 again, you'll get true, you'll move to 4, low to 4, high to 4, you'll get mid equal to 4. After you get mid equal to 4, you will make this grid for L equal to 4, and after doing that you will get a false, so your answer would be 3. So that's the whole algorithm for this question. I'm gonna just show you the code now, like what I have explained right here. So yeah, so this is the code. First I've taken the input and I've stored in the grid in my vector. After that my low is 1, high is n, and I have initialized my answer variable to 1. After that I have applied my binary search. While low is less than equal to high, I found the mid, and then my function to calculate if for that mid, that means mid is equal to L in there. So mid equal to L in my example. So if I can make this BS function, so shows if I can make a L into L grid, if I can find a L into L grid, right? And now I've done that. I've made a prefixum array, 2D array, and this thing which I told you that I'll convert it into a 0 1 grid. I haven't converted it into a new grid. I just have taken the prefixum like this. If the number is less than the num is nothing but mid, that is equal to L. If the number is less than L, then I've taken 0, or else I've taken 1. I'm using tertiary operator in here, so not a big issue. And I've made my prefixum this way. So if you don't know how I have made this prefixum, again I'll tell you to go to this website and check out how to make 2D prefixum. The examples given are very good. Like for example, if you need to find the prefixum of this, just see on the screen. If you need to find the prefixum of this subarray, You need to add this, subtract this, and add this. It's a very really good article. You can go on this website to find out more about 2D prefixum. So again, I made my prefixum array, and then I found the sum of every L into L size prefix, L into L size subarray. I started from if the size of L is equal to 3. So I'll start from 2 into 2 index, and then I'll check the sum. If the sum is equal to L square, that is num square, then I'll return 1, that is true. If I go through all the subarrays and I'm not able to find all the subgrids and I'm not able to find any sum equal to L square, then I'll return false. If I get it true, then I'll set my answer to this and update my loop, else I'll update my high. Okay, for this high part, if you can't find a subarray of size, okay, let's see in some test case. Let's see in some test case, if you're not able to find the, let's see if it was maybe a bigger size subarray, let's see, and you can't even find a subarray of size 4, subgrid of size 4, in which all the elements are less than equal to 4 or greater than equal to 4. So it's obvious that you won't be able to find a subgrid of size 5. It's the same logic which I used here. Like if you know that you can find a subgrid of size 3, then it's true that you can always find a subgrid of size 1 and 2. By the same logic, if you cannot find a subgrid of size 4, then it's obvious that you can't find a subgrid of 5, 6 or up to n. So that's the logic which I've used in this code, and then I've just returned my answer. So that's it for the tutorial of this question. If you have any doubts, you can just comment down.